you very much. So first of all, thank you all for coming out tonight on such a cold, literally snowy, unpleasant evening. Appreciate you taking the time out. We're a lecture on behalf of University of Salford and Xperi, talking about some collaborative work we've been working on over this last couple of years. My name is Ted Laverty. I am based in Northern Ireland. I've been working at the company I joined 25 years ago was called DTS, Digital Theatre Systems, and I have been spent my entire career in audio as a musician, as an engineer, as a I think my proper title is odd job, but over this last couple of years I've been focusing on international standards and looking at how we can actually improve consumer experiences. So, you know, the issue about dialogue intelligibility is something that everybody is aware of because you experience it. So part of what I'm doing here is trying to set the context, you know, like a good engineer, what is the problem we are solving? Number one thing. So video has done very well in this last couple of years. There's been thin screen TVs, you have got high dynamic range video, absolutely unnecessary high levels of refresh rates on TVs. You have got wonderful huge screens. I remember going to CES and it was, you'd be getting a 115-inch screen and it would cost like, you know, 50K. Now you can buy them in Tesco's. And you've also got 8K resolution. And as I say, I have seen the EBU tests on 4K versus 8K, but the technology is in the room. Video has never been better. And then, of course, it is the aesthetics of people's room. It is wafer thin. Doesn't use the same power as old plasma. So video is great shape in the consumer experience right now. However, as I said, as an audio guy, the challenge is you got two tiny $5 if you're lucky backfiring speakers stuck in the back of this amazing moving picture. You have got not a lot of actual power to move the audio. And you know, have you ever seen the devices? And I remember years ago doing projects with Pezio tweeters in the 1970s and 1980s. That's the kind of what the average speaker you find in the TV now reminds me of. Very good for hobby electronics projects, circa 1979. Not so sure now. And of course, the other thing you get is massively compressed dynamic range. You know, I think back to the days of CRT, which I don't want to go back to, but you had big chunky cabinets with big chunky speakers and big chunky amplifiers, and it shifted air, and you could, you know, but anyway, the industry has spoken and we want better video. Or has it? So you then get into the Friday night viewing cycle where, you know, I certainly, this is something that, you know, from my days as a mixing engineer, I'm surprised to still have to be doing it while watching TV, where you get your remote control, and next thing you get loud music and effects, you're looking to mute it down. It's like, you know, it's disturbing other people in the house. It's like, this is a problem. So then you find the remote and you're turning it down, get it to a more manageable level. That's fine. We're good for now. Then you get to the next soft scene and people are talking. And it's like, okay, so I don't understand what they're saying. This is not coming across. It's like, okay, get the remote, find the remote, and we turn it up again. It's like, okay, right, I can hear what they're saying now. Excellent, that's fine. And then, what's happening? We go back to the soft scene that we've just listened to it again, and it's like, okay, right, we can understand. And then everything's fine until you get to the next thing of loud music and effects, and you're back to that constant cycle. And as I say, I only discovered that this particular next bit has audio in it, but I think it's meant to demonstrate the issue. Then you get mixers that will actually make their films to purposefully blur the dialogue, and that's when you end up with Tenet. And basically anything that, you know, let's just say Thomas Hardy is known for many things, but I'm not sure he's going to be doing Shakespeare with great precision. So this is an issue that has entered into the public domain and public discussion quite a lot over this last sort of, you know, certainly 10 years. Like I remember seeing the front cover of the Daily Mail after the BBC had put out some of their stuff. My friends in the BBC and absolute conniptions where the big complaints about regional accents and bad mixing, and we can't understand what's going on. We're now seeing that, our friends in Netflix, most people are now, like over 70%, are watching Netflix with the subtitles on. So there is an issue about how people are receiving audio and the problems and associated stress that they're having. So this is something that our company has been engaged with and involved with. And that's not what I'm really here to talk about, because this problem is something that has been talked about for years in standards. There was work done back 15 years ago using metadata and 5.1 trying to solve so the point is there's not a silver bullet that's going to cure this overnight. It's a broad range of approaches and techniques that have to do with the electronics in consumer electronics, mixing different systems. Ben will go into a lot more detail, but this is a problem that needs to fix. You've also got the other issues of aging populations, and for my 8 years in the music industry, I know that my top end isn't as good as it should be or could be. You're seeing political movements now down in Westminster where people are seeing this as an issue. So really, where we're coming from as a company is this is a big problem, but we saw an opportunity to work with the University of Salford to help bring some engineering rigor to how we can actually add something to solve this for everybody, because this is something that affects us all. Ben, I'm going to hand over to you, and you can talk a little bit about the history and your stuff.
Cheers, Ted. So I'm Ben Shirley. I'm an associate professor in audio technology here, and supervising Will, who's the main act of the day, his PhD. So what I'm going to cover, we've talked a little bit about the challenges already, a little bit more on that from Will. A bit on the previous research we've done. So I think I first met Ted about 11 or 12 years ago.
In days of object-based audio and IBC drinking, yeah.
When we were looking at how we could use different formats to improve things for hearing impaired people, make the sound better in the very early days of talking about objects and so on. And then move on to Will, who's going to talk about the current research project that we've got ongoing with his PhD. So the challenge, it's obviously speech against competing sounds, or that's the way it's usually framed, as a kind of binary thing. If the speech is useful, the competing sounds are potentially masking sounds. The cause of that, it might be the technology, it might be the tiny backfiring speakers, it might be production values, it might be actors mumbling, it might be people being hearing impaired, it might be the dynamic range from compression used in broadcast. All of those things. It might be inappropriate down mixing at the set-top box, which I've come across a couple of times at home, which has been just calamitous, and I've switched it off and then realized that, oh no, we can fix that. So the previous stuff we've done, which has kind of led to this point, I guess, we started looking at the kind of opportunities that we had. And I first did this, it was very early days. My first bit of research was commissioned by the ITC, for those that remember the ITC, before Ofcom, which was just as we were coming up to digital switchover in 5.1, and what could we do to make TV sound better for people with some hearing impairment. And then we had came kind of full circle and back to there's another new opportunity, NGA audio formats, which potentially allow us to personalize the audio experience using objects. How many people are familiar with audio objects already? So everybody, almost everybody. Okay, so very, very brief description of what is object-based audio. So essentially in channel-based audio, which we're all kind of used to for years and years, we've got all these different elements in the sound scene. So there's some background noise, there's footsteps, Foley stuff, some reverberation, there's dialogue, there's some fan noise here, there might be some background music, and that's all mixed at the production stage, and that mix is sent to you and you don't have any options with it. That's what you have. That's kind of traditional broadcast. And when these new next generation audio formats came along using objects, the world potentially changed a little bit for how we could personalize stuff. So potentially, we've got the potential of sending these various different elements, or some of them along with a channel bed, of sending those out as part of the broadcast, tagged with lots of metadata that describes what they are, what they're for, what they're used for, how loud they should be, where they should be placed, all of that kind of stuff. and that could be remixed by your smart TV or your set-top box. So obvious things that you could do is you could lower the level of all the potential masking noise, raise the level of the dialogue, so that might fix the problem. So we started looking at this initially with DTS. We did a bunch of stuff with, as I say, about 11, 12 years ago, and ran some demos at IBC and NAB and things like that, kind of exploring different elements of the sound and what people wanted more or less of. One of my MSc students ran a really good project where we got lots of hearing impaired people in and we gave them some options. They could change foreground, background, dialogue, music to different amounts to see if it was a useful thing to do, essentially. The main answer being, when can I have it at home? So yes, we need to do that. But actually giving them a mixing desk wasn't a very, very good solution. So it's how could we present this in a way which is nice and easy, simple, effective, that works. So we came across, initially when I was working with Rob Oldfield on a big European project, and then this was picked up with a PhD by Lauren Ward some years later, the idea of having narrative importance and the importance of each sound in there to understanding the story, and it not necessarily being just the dialogue that's important, just the speech that's important. So we had this idea of we categorize these things, and dialogue's king. That's always going to be the most important thing to understand in the narrative. And probably the distant wind in the trees and the ambient music and so on is the least important, but we were basically saying it's not just binary, there's some other stuff that's super important in there as well. Sound of a gunshot in a thriller is probably quite important, that kind of thing. So we kind of categorized these sounds, and we worked on a really interesting project, the S3A project, where we worked with some sound, with some producers, categorized them in 4 different categories, and then treated it in various ways, just with a single kind of dial control, or we could do it with a slider control, which was basically making it less complex. So the essential sounds, as you turned towards the accessible mix, the essential sounds would be raised in level, and the less important sounds would be reduced based on how important they were, which kind of worked. It's quite neat. It's quite a good solution. We did some trials with the BBC, so we did a couple of episodes at Casualty, as I say, with Lauren Ward leading on most of this stuff. Worked with the producers, worked with the viewers as to what they wanted, production staff and so on. Got some really good feedback, some really interesting stuff. So a sound like the machine in the hospital that goes beep, beep, beep all the time, which is just ambient background noise most of the time. But when someone's heart stops, suddenly it's really important to the story, and that suddenly becomes narratively important. So these things were changing all the time, so you had to have kind of dynamic metadata. Got some great responses. Some of the hard of hearing people basically saw it as it was empowering because they could mix it for what they wanted in a nice simple way. Production staff, surprisingly, at least TV production staff, there's some less positive reflections from movie production staff, but TV production staff, well, this is great because I can mix it so it sounds fantastic and I don't need to cater for everybody that's hearing impaired because that's done by the technology. That's really good. So that worked really nicely, really nice project to work on and so on. But we don't have object-based audio everywhere. All these things work very nicely in a research project. We're actually in a world where there's legacy content, there's current channel-based broadcasts and things, but we do have this rather useful kind of speech separation stuff that's come to the fore over recent times, where we could separate out some of these stems and potentially do some of the same work without it being object-based all the way through. So Xperi, i.e. Ted and Martin, had a chat with us and said, how do you think we could work on this sort of, how could we use these kind of stem separation techniques and so on, and more importantly, how could they be implemented so that they would be most useful, both for people that are hearing impaired, but also all the other people that complain about not being able to hear the dialogue on TV. It's not just hard of hearing people. And we came across this idea of comprehension versus intelligibility, because the level of the other sounds in TV broadcast compared to the speech is such that if you were running an intelligibility test, the word recognition rate would be 100%. You would spot every word. But people are still complaining that they can't hear what's going on, they can't follow what's going on. So there's some other stuff at work here which we started talking more about. Actually, it's more important than the audio is comprehensive, that we can understand it, than it is that we can pick out every single word. So two slightly different things which are usually kind of combined, if you like. So that was the start of where Will started, kicked off the PhD kind of thing. What do we mean by, what's intelligibility? What do we mean by comprehension? What are the stages in this kind of thing? So I'm going to hand over to Will now to go through the work he's been doing over the last couple of years as part of his PhD. It's all yours.
Cool. Thanks, Ben. Hi, everyone. So I guess picking up where Ben's just left off, I'm going to start looking, I guess, a little bit at just of the sort of state of what broadcast content's like at the moment, and sort of how maybe these ideas around comprehension and intelligibility maybe sort of playing a role in the problems people are having understanding dialogue. So over the past 10, 20 years or so, there's been quite a lot of research into kind of providing people clear and understandable dialogue in broadcast content. And as a result of this, we've got a whole load of guidelines and standards that people can apply to make sure that the content they're producing is clearly audible and intelligible. Essentially what this tape graph is showing on here, the orange box is kind of the range that is sort of common within broadcast practices from one survey that was done a few years back. And just to be clear, the numbers up the side are essentially the sound-speech background ratio. So there's the level of the speech relative to the kind of background sounds in the content that was surveyed. The pink line is showing the kind of recommended minimum loudness difference. That's recommended by the UK DPP, Digital Production Partnership. And the blue line is showing sort of around where you'd expect around 100% intelligibility for listeners without any impairment. So as you can see, as Ben mentioned previously, you would really expect that most viewers would be able to hear most of the dialogue quite clearly and shouldn't be really having problems with intelligibility so much. So despite this, there's quite a lot of evidence that people are still having problems understanding dialogue. A survey by the BBC in 2010 found that 60% of viewers have trouble hearing dialogue. But then when we fast forward to 2024, recent surveys put that number as high as 84% reporting difficulties with understanding. There's also reports of increased subtitle use, with as many as 85% of Netflix users making use of closed captions. And this phenomenon seems to be sort of disproportionately affecting younger viewers. As many as 63% of adults in one survey, saying under 30, saying that they were using subtitles, and that was, as to put that into sort of that's sort of compared to, I think it was only about 30% of viewers over 65 that were reporting the same. And so when people were asked why they use the subtitles, around 66% of them said that it was better to understand the storyline. 40% said that it was to improve concentration. 40% were saying that it was to enhance comprehension. Actually, less than a third of the subtitle users were saying that it was because of difficulty hearing the speech. So one reason for this might be due to the ways in which we tend to measure dialogue understanding. The most prevalent metric for intelligibility used for accessibility is word recognition rate, which is essentially the percentage of words that people can correctly identify. Kind of one of the problems with this is it's quite ineffective using levels that are actually representative of broadcast content. So in order for people to have a measurable effect, people have to use conditions that are quite extreme and are unlikely to actually be found in content. Additionally, it doesn't really affect understanding. To hear a sound and repeat it back, you don't necessarily have to understand what it means, and it doesn't actually necessarily have to carry any meaning at all, which is what I'm kind of trying to demonstrate with the Live Aid picture. And yeah, additionally, it's sort of a binary indicator, did they hear the word or not, and it doesn't give any sort of nuance or indication of the challenge or the quality of the listening experience for the users. So so while doing more testing of this kind might be useful for those people that are struggling to hear, it's not really going to help any of those people that are struggling to follow the storyline or are struggling with their attention or their comprehension of what's going on. So really, I guess the first experiment that we've done in this project, the idea was to kind of like try and look at some ways in which we can measure within the more relevant broadcast range, and also to actually take a more holistic approach that can take into account some of these other aspects of speech perception that aren't so often measured in accessibility. So the listening test, it was about a year ago now that we did this, and we had 30 participants. These were all adults between the age of 18 and 36. They were all native English speakers with no hearing impairments, so all people that generally had pretty good hearing. So the stimulus we used were 2-minute radio clips. These were clips of an audiobook narrated by Bill Bryson for BBC Radio 4. There was background noise added at different levels, and the levels we used were sort of meant to represent that broadcast range. So we had 4 LU, which was that the DPP recommended minimum, and 10 LU and 6 LU, which is kind of the bottom and top of the common broadcast range. And so when the participants came, initially they went through the training. We set up EEG because we were recording some neuroimaging stuff as well while we were doing this. And we also took some psychometrics so we could get a kind of baseline for people's memory and people's hearing. It's like a speech and noise test and just a verbal memory capacity test that we could use to kind of put our results into context. Once people had listened to these stimuli, they were asked to self-report on 5 scales. These were audibility, so how clear and audible the words were; mental demand, so how much thinking, remembering, interpreting was required; frustration, which was essentially how annoyed were they while they were listening; engagement, so how interesting they found it, and particularly like whether or not their mind was wandering or if it kept their attention throughout; and also effort, so just how strenuous they found the listening experience. And then following their self-report scales, they completed a recognition task. And this was a way of us measuring their comprehension, but as well as getting an overall idea of their comprehension, it was also probing to get an idea of how strong their memory was for like the wording, the information that was conveyed, and also how strong their sort of more contextual understanding was, whether they could discriminate between correct and incorrect information based on what they'd just listened to. So the results of the self-report scales, I guess the main thing you noticed here was that there was a significant effect even with the like more modest changes. So even within that common broadcast range, we still saw a clear effect of the different background conditions. And across all of the scales and every different signal-to-noise ratio pairing, people were reporting more negative ratings overall. On these scales at the bottom, audibility and engagement have been flipped, so all of them, high score is negative, if that makes sense, just to keep everything kind of uniform. So even when the dialogue was constantly above threshold and clearly intelligible, there were significant changes in sort of the listening effort and other aspects of like the listening experience that people just found increasingly negative. Another thing that I thought was quite interesting with these results is if we look at the correlations with the psychometric data. Interestingly, so on the left, this is kind of the hearing scores from the speech and noise test, and on the right, this was correlated with the verbal memory capacity scores. And what was quite interesting was we didn't necessarily find correlation with people's hearing, I suppose because it was all above threshold. We would expect people could hear it all pretty clearly. But every single scale did correlate significantly with the memory scores. And I guess you might expect that for mental demand or for engagement or effort, but I thought it was quite interesting, particularly the audibility. It was that people's perception of how audible the speech was more closely related to their memory than it was to their hearing, which was an unexpected result. So the next question was whether or not these changes within this broadcast range would actually translate to poorer comprehension scores. And essentially we found that they did. there was a significant effect of the background noise on the overall comprehension scores, and we saw just a general monotonic increase from condition to condition. Again, kind of interestingly, the biggest drop was actually between the sort of best and the sort of moderate conditions. So there was a greater effect on how much people remembered, how much people understood, going from the top of the broadcast range to the bottom than there was to going right down to that more extreme listening condition. And to break that down a little bit more and look at the different components of that comprehension score, all of the subcomponents did have an effect from the background noise, but they were kind of affected in different ways and at different points. So the sort of memory for the wording seems to be affected first. So with that sort of more moderate increase in background noise, we saw quite a big drop in people's memory for the specific wording that was used. And then when we increased the background noise further to the more extreme condition, that's when we actually saw a bigger drop in the sort of memory for the information. And sort of throughout, we saw a consistent drop in people's sort of ability to discriminate between the correct and contextually correct information. So I guess kind of the interesting effect that we see here is that while the comprehension was affected, it wasn't all affected in the same way at once. We kind of saw that people's memory for the fine detail was diminished first, and then kind of that informational content was becoming harder to retain, and overall just like a consistent like downward trend for people's overall understanding of the stuff that they were listening to. So as our interest wasn't just in sort of how the listening experience and the comprehension fluctuated with the conditions, we also want to try and work out ways that we can mitigate these effects and try and get an idea of other ways that we might be able to apply some of these new audio technologies to actually improve the problems that viewers are having. And specifically, we were trying to find out what acoustic properties of the speech signal were related to the participants' understanding and their subjective experience. And to look at it, we used electroencephalography, or EEG, to record the brain activity throughout the listening test to allow us to examine the brain's response to these different speech features in real time. This gave us a way of looking at how the brain was tracking these different acoustic features and how that changed as the listening became more difficult. So we focused on two simple features of the speech. One of these was the acoustic envelope, which is essentially the rhythmic amplitude of energy fluctuations, and second were the sort of speech onsets, so the sort of sharp increases, particularly at the starts of words or stop consonants. And so the results showed that there was an effective signal-to-noise ratio on both the acoustic onset and the amplitude envelope-related responses. But interestingly, they kind of moved in opposite ways. So the onset responses seemed to decrease as the listening demand increased. For context, these graphs were basically just set 100 in the low condition as a baseline, and so showing the effect relative to the easiest listening condition. And so as you can kind of see, the onset response, the magnitude of that response reduced up to about 30% by the most challenging condition, whereas when we look at the amplitude envelope response, that actually rose to almost as much as 50%. And what you see on these plots here is essentially these are the kind of actual averaged responses over, say, like 600 milliseconds after a change in the signal. And as you can kind of see here, with the purple being the easiest condition, the yellow being the hardest condition, there's a clear drop in the amplitude in line with the increasing demand. Again, when we look at the amplitude of the envelope responses, these are obviously seeing much bigger peaks. So additionally to this, there's also strong correlations between the size of the onset response and the amount of listening effort that was reported by people, as well as some smaller areas that were related to people's comprehension, but very, very strong and widespread correlations with listening effort and the response to those onsets. Yeah, so moving on from this, I guess those results raise some kind of interesting questions about how we might be able to mitigate some of these problems. Having seen these sort of like different responses to like the envelope and these onsets, we're kind of starting to wonder if there might be ways in which we can specifically enhance these features, and possibly at different levels it might be that these different features are more useful or less useful, and that might be something that can actually be used to our advantage when we're trying to design sort of enhancement techniques. So we've been working on some approaches to possibly enhance and boost these different aspects of the speech signals, and we've got some tests coming up, which will be the next sort of stage of this project, where we will be selectively enhancing both acoustic onsets and speech enhancement there, I should say amplitude envelopes, and basically see within the same kind of range of background noise whether or not we can actually see any positive effects on people's like experience of effort or their comprehension as a result of sort of boosting these different features. Yeah, so I guess a few kind of takeaways. First of all, obviously object-based audio and also now source separation offer us a lot of ways to personalize audio experiences for people, which not only could be setting levels, but also lots of other things, such as the sort of narrative important works, and also possibly lots of other things. I mean, it seems clear that boosting dialogue can offer benefits beyond just intelligibility. So just because people can hear 100% doesn't mean that pushing up the dialogue further is not going to help them and make understanding easier. I think also we need to look at more holistic approaches when it comes to accessibility services. Like I said before, most of the methods we use currently are looking at intelligibility, word recognition, and I think taking into account more things like memory, attention, and a lot of these other cognitive aspects could really help to improve services in general. And finally, just 100% intelligibility should be treated as a minimum requirement and not the gold standard. We should kind of be aiming for content that goes beyond intelligibility and trying to facilitate better viewing experiences and just easier understanding overall. And on that, thank you very much for listening. I think that's all from me.
So I think we do have time for discussion or questions and answers or anything like that. So,
can you explain the comprehension test and the way that you were looking for wording, meaning, context, and all of that kind of stuff?
Yeah, absolutely.
In a bit more detail.
Yeah, of course. Yeah, I kind of took a lot of the detail out of that because I was worried I was going to go on too long. But
no.
Did the opposite. Right, so I don't know if that necessarily helps. So yeah, I guess so in terms of the comprehension task, a bit more detail on that. The idea really was that people were just presented with sentences and asked whether or not these sentences were heard in the stimulus they just listened to. So it was like a simple yes/no response, which is quite nice for participants, nice and quick. And basically the way in which we sort of probed for these different aspects of understanding was to change the sentences in different ways. So there were 4 categories of sentence that could be presented. We either had sentences that were taken verbatim from the stimulus script itself, sentences that were paraphrased, so they contained information that was exactly the same as a sentence from the original stimulus, but the way it was phrased or worded was changed. There were then sort of inference statements, and these were statements that had to be true based on information contained in the stimulus, but weren't actually spoken explicitly. So completely correct, but not actually said. And finally, you had sort of almost incorrect inferences, so inferences that could not be true based on what was said in the stimulus, but yeah, well, just couldn't be true. And basically the way it worked was it was a kind of, if anyone's come across signal detection theory methods before, but the idea was that by comparing sort of each step of change that had been added to these original sentences, you can sort of see from the mistakes people make how strong a certain aspect of their memory was. So take, for instance, if you have the verbatim sentence and you have a paraphrase sentence, by comparing the amount of yes or no's to those two sentences, you can see how strong their memory was for the specific wording used compared to the information. If you were to compare the paraphrase sentences with the inference sentences, both of these sentences were sentences that were correct and true based on what was said in the stimulus, but only one of them was actually information that was presented. And so you go on one step further and you compare the inference statements to the incorrect inferences, and that gives you an idea of the sort of ability to discriminate between contextually correct and incorrect information. And yeah, so that was essentially how that worked, and that's what these scores here are essentially showing you, is the sort of comparison between the sort of yes responses to these different neighboring sort of sentences or memory probes.
So is the contextual stuff the correctness?
Yes.
Yeah.
Yeah, so I should explain that.
Yeah.
Yeah. So that would be the kind of comparison, or the kind of, I guess, the contribution of the of kind of whether or not information in the probes was correct to the overall decision-making thing. So how much that affected whether people say yes or no to a certain.
So the first thing to go is what words, the intelligibility almost, what
Yes.
words were said.
Yeah, 100%. Yeah. So it was really that sort of fine detail that, like, the memory for the specific words that we used goes early on. Then we saw a big drop in the kind of information later on, and the kind of correct, I would say this is probably the closest to kind of overall understanding, and that was sort of just dropping off consistently throughout.
I suppose one thing in terms of context, which is important as well, so like in Xperi, we're a technology company, we're bringing out products every year, and we've seen this as something that's really important. Where this works as a nice relationship, we developed a system which didn't depend on metadata in content creation. It was like a post-process. But it became clear to us there's so much more understanding is needed across the industry. So it was great to actually work with an academic partnership, and like Ben's reputation in this field goes back for decades. And it's, this is the kind of stuff that we were always interested in, but never had the resources to actually apply. So it was very nice to actually have, someone focusing at these things, looking at a cognitive load, doing these sort of very objective sets of tests and measures to work out how we experience sound. And and this is something we want to present to the industry. This is an open PhD. All results will be available for everybody involved in this, because you've got from a crappy sort of boosting all the mid frequencies on some TVs to make it better, which is horrible. You have got metadata approaches, as Ben said, which are fine if they're there, but that doesn't work for legacy content. We're developing stuff as ML post-processing, but it's like, it's a big problem. This level of research needs to be done to get that true understanding about what's going on in here. And as I say, certainly 2 years into the project, it's been very, very useful for us. And I say University of Salford have been great partners.
Ian, I've got a question. I suppose the key thing for me is this growth in younger audiences making more use of subtitles. Is there strong evidence of any particular cause, or is it a range of causes?
It's a good question. I don't know if I've necessarily seen really strong evidence of any particular cause. One thing that's often cited is kind of things around the idea of like attention and things like that. A lot more young people are like viewing while also on a phone or doing something else. And viewing habits, particularly with younger audiences, are changing a lot. People are multitasking, so having subtitles means you can be paying attention to two things a bit easier. It's just like a bit of redundancy, isn't there?
I would also suggest that for those of us that remember CFAX, closed captioning is so much better now today than it was back in the day. You're actually able to get nicer fonts, text. So to have it on, it's less of the seeing your equivalent of your 8-bit audio chundering away underneath with sort of lots of cyans and magentas. I think it's partly to do with people using multiple screens, but it's there because the audio is not delivering what it needs standalone. That's one of the challenges. And it's not just old people like me that have got my ears blown out by guitars over the years.
Well, all I know is my 24-year-old daughter can't actually tell me why she prefers it.
No.
It's a preference for her. She doesn't have any particular explanation as to why she likes having that, even when those closed captions are actually quite impacting to the visual experience. Because if you've got old closed captions on content of the 1990s, they're basically taking up a third of the screen.
Yeah. And it's terrible for watching comedy with closed captions because all the timing's lost. Don't watch Stuart Lee in closed captions. It doesn't help. Yeah.
We did have some conversations around looking at some of the same kind of measures and the EEG and so on with and without captions as well, didn't we?
Yeah.
But it turned out to be, there's only so many things you can test in one experiment without it starting to get quite messy. But that would have been quite interesting to see whether the result of that, or possibly the reason why your daughter's doing this, is to reduce listening effort. It's not necessarily vocalised as that, but it's just more comfortable to understand, which might have been teased out by that.
Conscious to her as to why.
Yeah.
Just prefers it.
Well, it's one of the things that I was really excited to see in the results was going and looking at cognitive loading and just how your actual brain is operating when you're trying to listen in. It's like, when my kids were young, it's like, I am now in a high intensity driving situation, so no conversation, I'm changing lane. Your brain, it's like the jet fighter pilot syndrome. If you're putting that level of work in, it's making you uncomfortable, so anything that makes that more tranquil, the better. And being able to, we're not wiring people up to brain scans in our offices, but it's great that you guys could, so you could actually see part of what was going on there. It's as I said at the start, this is a big problem. It is a problem, and there's not one solution. But the greater that we understand how the hell is we're actually perceiving, and as I say, if you're feeling tired listening to the audio, yeah, you're probably watching.
It does raise an interesting question, because I know my mother-in-law suffers from this, and that's white coat syndrome. Did you account for white coat syndrome in the sticking a great big hat on people and making their ECGs?
Well, yeah. So it was definitely a kind of, because a kind of big part of it was we were trying to go for sort of ecological validity. Largely speaking, the kind of thing with some of the word recognition metrics that we kind of wanted to avoid is you just got like single sentences, right? And so here's one sentence, and it's like, what was that word? But when you're actually listening, watching TV or something, it's like you're watching half an hour of content, maybe more. Maybe you watched an episode a week ago, and you've got to remember what happened. So using completely out of context sentences doesn't really give a good representation of, what's going on. So there was a lot of thought on how to make it really ecologically valid, and then we were sticking hats on people and covering them in goo to measure their brains. It sort of may have made some of that a bit redundant.
I think that might have reduced the ecological validity.
Maybe a little bit, but hopefully the fact that we were using like real content and longer excerpts kind of makes up for that. And so we kind of added a bit of ecological validity and added a bit of white coat syndrome there, and I think it balanced out, I hope.
I think the most important conclusion is further study needed.
Yeah, absolutely.
Could you outlook, because you've got another experiment going live soon, haven't you? It might be worth outlining some of that.
Yeah, so yeah.
Sorry, Will.
No,
Yeah.
that's all right. Just was wondering if you knew about the information rate of your stimuli. Did you phonemes per second, that sort of thing?
Yes.
Potentially there might be an interaction between signal to noise ratio and the speed at which information is coming in as well.
Yes.
If you thought about that.
Yeah, no, definitely. I haven't gone quite into phonemes per second necessarily, but I do know it was it was 2 minutes, it was about 300 words on average. Each of the stimuli was give or take 15 words, I think. Some of them had a few more. On average it was about a word every 400 milliseconds, which annoyingly I don't actually have the graph for this because I didn't want to go that deep into
It's the IET, they go deep.
So if we look at these waves here, we can't actually see it on these because I don't have the right plot, but essentially we also, as well as these particular features, we looked at a few other things, and one of them was kind of just like the beginning of words, so just like instead of using an actual feature of the speech signal, just looking at put an impulse at the beginning of every single word and see what the sort of average response is. And so for within like ERP and other EEG tests, there's a component that's called the N400 response, and so that's kind of like generally related to the kind of context of words. So around 300 milliseconds, we identify a word after we've heard it, and at 400 milliseconds, or just around there, it's usually like sort of between 300, 400 here, you'd see a dip. And when you see that response, that's sort of related to integrating that word into the kind of broader context. And what was quite interesting was in the best listening condition, that N400 response was always solidly on average between 300, 400, and even by the 10 LU condition and further, you actually see that response pushing past 400 milliseconds and even further on. So it kind of looked as though the inability to integrate that word and actually identify the word and its meaning before 400 milliseconds was diminished as you kind of increase this, and that one of the strongest correlations with the kind of comprehension results was actually the presence of that N400 response before 400 milliseconds. So kind of related to the rate thing, it's like the rate of the words was 400 milliseconds. If people weren't identifying and integrating those words before the next word came, it was having an effect on people's understanding.
So if you could remove, say, link words like particles, like linguistic particles, which have no like semantic, like waste, they're
right.
anything,
Yeah.
but they're giving people time to understand the bit that they're dealing with. And you can maybe see that, like, once that goes past the time you've got the next keyword come in, then people are starting to drop stuff out.
Yeah, for sure. Yeah, and there are some people have done some interesting tests with that kind of thing, like weighting, like, so kind of the similar things to what I just described, but looking at actually function words versus like other words, or like actually looking at kind of semantic surprisal and how that affects it. And it was something we looked at a bit. I played around for a while with like BERT embeddings, but it was a rabbit hole that wasn't worth digging down. But interesting to look into more for sure.
You need a more elegant solution for high rate Glaswegian and Northern Irish accents.
Just a quick question.
Yeah, go ahead.
How did you select your radio clips, and can we listen to it?
Right. I could probably put a bit of something on. Not got any copyright approval, but I'm sure if it's a short enough clip.
Yeah, that's fine. We'll tell you that. While you're looking for that, what was the background noise?
It was pink noise essentially. Yeah. Just fairly straightforward, just so we didn't have to complicate things too much.
You want to keep it as linear as is possible within the sets of the experiment. So you're not going to have like a random cocktail party recording in the background, because that's.
Well, this is the question of ecological.
Yeah.
We did look at having kind of speech-shaped noise and things like that, and having it modulated at kind of speech rates and
Or
things.
even just speech-shaped noise.
Yeah. But it was
So I don't actually know if I've got them mixed.
once you start adding the modulations in, you're kind of tying it to a specific genre of programming.
So if it was pink, just 22.
I think it was shaped, wasn't it, so some broadcast content.
We did actually,
the pink noise. It was shaped to be.
It's true.
It wasn't flat across. It was shaped to be
what we've done is
based on some broadcast content.
Yes, we used some. Atmos from some broadcasts. It was like a city Atmos from something, and we used the average frequency. Yeah. I don't have it mixed. I could probably play you a bit without the.
I can imagine.
without the pink noise.
You heard it before.
The experiment was done in
volunteer
Max,
to make some pink
Max
noise.
MSP, so the background was mixed in like real time, and so I don't actually have mixed versions ready to go. But this should be a little bit of it. Play.
The great paradox of the brain is that everything you know about the world is provided to you by an organ that has itself never seen that world. The brain exists in silence and darkness, like a dungeon prisoner. It has no pain receptors, literally no feelings. It has never felt a soft breeze. To your brain, the world is just a stream of electrical pulses, like taps of Morse code. And out of this bare and neutral information, It creates for you a vibrant, three-dimensional, sensually engaging universe.
Yeah.
You've heard that before, haven't you?
Yeah, oh yeah, a few times. I sat through 30 experiments.
Sing alonger. Yeah.
But yeah, so that was essentially what it sounded like. Unfortunately, I don't have it mixed, but
I can imagine.
yeah,
Yeah,
and
I'll go.
It's relatively like clean speech in the
Yes.
Mm.
Yeah, exactly. Yeah, and like I guess kind of part of the choice of the kind of Bill Bryson stuff was it was like it worked quite well because you could find 2-minute clips that kind of stood on their own as like little factoids, so people could kind of develop an understanding of one little topic, and you could, so it's something that's had quite a lot of broad appeal. Most people would find fairly interesting, so people aren't going to get bored and sort of switch off. And yeah, it's just like a bit of information to put across facts that people probably don't know or don't know all of. So it kind of worked quite well for that purpose.
We looked quite hard.
Oh, it took a long time.
Comprehension type test, but I think it's really hard to find anything useful.
Yeah, and there's been many dead ends along the way as well.
Yeah.
Like if you're looking for other stimuli like that, the moth has been quite a popular one as well.
Yep.
Podcast
Yeah.
Oh yeah. Yeah.
and it's a similar, quite a high demand actually, which is probably.
Yeah. Yeah, it's worth looking at.
This is below my lack of knowledge of EEG. What does the response look like if they're if they're listening passively? So your N400 changes, but I think there's still a response earlier on.
Right.
And the thrust of that question is, does that change with SNR? So how much is the SNR, because they're not listening to the same thing, you've correlated it to listening effort and memory.
Right, yes.
But it's not the same stimulus, and I genuinely can't remember what the EEG looks like.
Right, so do you mean as in passively, as in?
So they're just presented with it, and they could be watching Netflix with the sound off.
Oh, I see.
Sort of what does the load look like? The load increase, the delta?
Right, so they're not paying attention.
Yeah, to what extent is the waveform that is actually hitting the ear changing the EEG?
Right, yeah, so there's still a response. So like even if like someone is like, say, like a lot of these tests, particularly the kind of method that I was using to analyze the EEG, the TRF stuff, a lot of it is, a lot of the early research was on attention. So like having two talkers, attending one of them and seeing how the response changes. And yeah, so basically you do get a response to both. Generally, the response to the attended talker is earlier and bigger, particularly like the early part, and those later, like you say, the later bits like the N400, etc., sort of disappears more, but the actual early response, the sort of sensory response and the attentional bit is still there. Kind of interestingly, when it comes to kind of onset stuff, is that when it comes to speech onsets, there's actually, so you've got the first component, should we put it up? It'll be a bit easier to explain. So like the kind of early components, like around this mark, these are sort of really modulated by attention, but also like the kind of salience of the stimulus. And with kind of the onset response, it's quite interesting when you have like a competing talker, is that despite it being kind of presumed to be a kind of quite an immediate response, it's like the information is passed up through the brainstem and then you have this response, is that you actually see a delay in the response to the attended talker. So there's some kind of, even at the earliest stages, there's some kind of attentional effect, like actually kind of pushing the kind of voice that's being attended to sort to the forefront of the thing, which is kind of interesting because it kind of potentially means that the way, when people talk about sort of like informational masking, things like that, actually that could be a lot to do with sort of attentional effect of sort of onsets of speech, which we're sort of automatically drawn to. It's quite an interesting idea.
So by salience in there, you mean salience due to attention, not salience of the stimulus?
Yeah, both.
Of in this case, the background?
Yeah, so both. Like the intensity of the stimulus also affects the early response. So like larger sounds tend to elicit a large response, but also whether or not someone is attending to that also tends to produce the same sort of effect. Yeah.
Do you think you would have seen different responses if Mrs. Bryson was reading it?
That's an interesting question.
Voice?
Yeah, it's an interesting question, and yeah, very possibly. Like, there have been results that have shown slightly different results. Well, I mean, to different voices in general, but also to male and female voices. While we're not doing EEG in the next experiment, we have actually recorded the same stimuli with a female talker, because we want to make sure, now we're looking at enhancement, that we're not kind of biasing the enhancement towards male voices specifically. So we've got like a duplicate of the same stimuli that we're going to be using with a female voice actress who came in and recorded some bits for us. So yeah, hopefully in the next experiments we're going to see how that affects it and what that difference makes. But yeah, I think probably.
And are you doing enhancement on both the onset and the kind of acoustic response?
Yes.
Yeah.
Yeah, so the enhancement, one of them is kind of like an onset enhancement, so it's like sharpening those onsets, and the other one is kind of like a modulation spectrum enhancement, so sort of boosting the sort of low frequency amplitude envelope, sort of both multi-band enhancement and then sort of summing that down to get the final output. Yeah.
How do you think this data can be used to improve the technology? Is it in the production stage where we can use this, or is it in the delivery side of
It's a good question.
I would respectfully suggest it's all parts of it. Now, craft mixers have been doing craft mixes for 100 years and they're damn good at it. The problem is whenever it's actually going out to the consumer space. So one of the important things from an industry point of view is trying to understand how people are hearing audio. Like you had this situation over this last sort of 15, 20 years where people are buying audio separates and sound bars because the sound's so crap coming off your TV. But in general, I think the biggest problem is in the home. I think, we've been mixing audio at wonderful levels for many, many years. And those those professionals could do it well. But you do get, Tenet is the classic movie that was brought out a few years ago, where, purposefully things are mixed in a muddy way. That's an artistic choice. So artistic choices in the mixing stage, that's absolutely the content creator's view. It's when you get it into the home that you want to be able to understand it. But understanding how people are hearing and processing audio is useful at all parts of the chain. But certainly our perspective was, in consumer electronics in the home is where you can actually help solve the problem, because not everybody's got a Todd AO 11.1 setup in their house, unfortunately.
But I mean, there are so many different, as you alluded to, there are so many different factors here. One of the things that several things that I'm very aware of is in the mix process, it's often the director who makes the decision, and the director knows every word of the script, back to front and upside. So
like you and your Bill Bryson.
Yeah. Because they know what's being said.
Yeah.
That's one element. There are so many other elements. The challenges of actually acquiring sound are getting harder and harder, because they go and recce a location, think brilliant location, but the audio is rubbish. Or, I mean, I can't remember what it was called, but it was a drama series where the Germans had won the war, and so there was lots of mumbling going on.
Man in the High Castle.
Yeah, in very dark spaces. So again, anybody who's even unwittingly is lip reading, fail.
Yeah. And this is where my 94-year-old mum wants a button she can press and goes, all right, that's what they're saying. That's kind of what the end user experience needs to be. And, no harm. My mum's had very bad hearing for many years, and I can't be in the same room with her as the television on because of it. So there's all kinds of issues about how you can actually personalize audio. But yeah, if a director makes a decision that mumbly or rapid high-speed Belfast or whatever, that's an artistic choice. And you're not going to fix that in the mix, but if you can bring out more of the intelligibility, that's something that people will find useful.
But you were talking about comprehension, and the way you were phrasing it almost started to make you think, do we not need comprehension meters rather than intelligibility meters?
You have to wire somebody up, I think.
Because
Might
the
be.
inference is that intelligibility, as in the way we currently measure it, isn't actually that helpful.
Yeah, I mean, it could be argued, and I think part of that, one of the things that sort of Ben mentioned as well is this is why the emphasis, I think personally, should be more on personalization and giving control to the home user, right? Because if the director's got this idea of, this is how my masterpiece is going to be set, but the person at home goes, the way your masterpiece is set, I can't understand what's going on. Then if they've got control and they can change it, it means it can still be boxed up and sent out as this kind of visionary masterpiece, but the person at home can have it to suit them, right? So I guess comprehension meters would be cool, but would be very, very complicated. So if you could just give people the control of the different aspects that can help them, and they can set it in a way that they go, I can understand it now, then they can be their own comprehension meter.
That would be fun. You get your standard 5.1 reference set up, you get your phase correlation, you get your, to see how your brain's working. Yeah, in the production environment, that would go really well.
Yeah. You can see.
The other thought is, if this separation technology is improving, which it absolutely is. Somebody who works with a lot of audio restoration, that very much moving on. Is it too simplistic to say, well, okay, object-based audio, brilliant. I mean, that whole thing Lauren Ward did and the casualty was just amazing. Just a single knob, was just absolutely brilliant. Is it too simplistic to say, well, why don't we use the separation technology to, in essence, give us the elements that object gave us directly, and then you effectively use that to give the end user a single control to improve being able to hear the dialogue.
To be fair, that's what we have been working on. My colleague Martin Walsh has been leading R&D on that, and it was the work that we were doing that ended up in conversations with Ben that led to this project. Because, I've been through the object-based audio wars. DTS has got its own object-based audio technology. It's in an Etsy document. We've been through the challenge you have, and you look at MPEG-H, you look at AC4, you look at DTS-X. They're great technologies, but they interrupt how people are making content today. And you get the pushback from there's this wonderful world of separate objects being sent out. People go, but I'm making my content in this way, and I don't want to be, doing these things that people can mess with my mix or stuff like that. So that's the reality. That is part of the solution. The other solution is to do ML analysis. And we did a project years ago with Queen's University Sonic Arts Research Council looking at source separation. And our conclusion from that was source separation is really hard. Really, really, really hard. But ML models have actually helped allow, you can get something that'll sit in the consumer piece of kit. And again, these are the products that we've been working on. But there's no silver bullet for this stuff. There really isn't. And if it's some guy from Ballymena talking at 500 words per second, no technology in the world will solve that.
If I may offer two points to build on what you were saying. I think it would be worth testing things like the casualty episode with this to see what the actual comprehension improvement was, because there's no blinding in that. People were saying that they enjoyed it, but we don't actually have the results from what was happening in that casualty thing. So it would be good to see if there was a comprehension improvement. And then to your point about the should be test comprehension rather than intelligibility. Everything builds on top of one another. So one of the issues that we have is that things like the AES report come out and say intelligibility is usually defined as this quite narrow thing, but we're going to define it as everything from audibility to comprehension. So that's an issue for a start.
Do you remember the loudness discussions and how long they took?
I mean, the loudness discussion is another one, because if you go to auditory science, that discussion is still happening, but it's done in audio.
Yeah, but we've stuff now across broadcast that's so much better than it was.
Absolutely.
And that's the work done by the EBU, and it's really good.
Yeah, but the discussion, that discussion isn't finished in other spaces. But so the way that I try and put it is that you have audibility at the bottom, you have no intelligibility without audibility, you have no comprehension without intelligibility, and then this listening effort thing. I've got a question about that, but I've just been talking for a while.
I don't think we're going to get thrown out of here for a while yet, so happy to continue the discussion.
So the memory thing was fascinating to me because 10, 15 years ago, everyone was talking about working memory, right, as the thing.
Right. Yeah.
And then somehow, at some point, that became listening effort.
Right.
But then you see this tonight, and we're back on memory again. So, is listening effort actually just working memory?
No, yeah, I wouldn't say so. Because I mean, listening effort is kind of quite hard to define and pin down. It's a bit, it's a bit of a nightmare. But like, you know, so like memory is definitely a part of listening effort, but equally like listening effort is also like affected by your hearing. You know, so it's not entirely memory related, and it can be related to like purely like threshold based concepts. I mean, I guess one of the things is there is that kind of memory aspect with some models where the idea is, and possibly why we saw these effects of memory on people's effort scores and things like that, is that the idea is that the more ambiguous the words are, the more difficult, even though you might be able to identify it, the more noise and the more difficulty there is, you have to hold more words in your head, more context to identify those missing bits of information. So I think that aspect is definitely working memory, you know, holding information and trying to identify the bits. But yeah, I think listening effort is, because there are some aspects of listening effort that are very automatic, like, you know, that's why you have physiological responses like pupilometry, etc., that can't really be described as working memory because they're so like automatic straight away, you know.
So in this stack, you'd have working memory as a part of listening effort?
Yes, I guess it's a factor that affects it, yeah.
We kind of started off talking about it as being kind of, first of all, there's the kind of signal recognition of word stuff, and then there's this kind of short-term memory of it, and then there's starting to put it into context, and then there's contextualizing it into a wider narrative or plot to make more sense, and it can break down at any of those points. So a lot of the EEG stuff was essentially trying to work out what was the point of failure. We didn't think it was just intelligibility because the signal to noise or the speech to other stuff ratio was, you know, such that it shouldn't be a problem to pick out words. So it was trying to identify where that came down. And the question of what listening effort is, I think that's the heart of what you're trying to work out with the EEG and the comprehension stuff, and understanding the difference between remembering the words and putting it into, and understanding the phrase and then putting it in the context of what's come before, and all of those kind of different things, which are happening at different times. So to some extent, the data is kind of messy when you start monitoring people's brains. They're messy places, but you could kind of see where these different activities were kicking in the timeline, which I think was quite interesting. And there was more later stuff kicking in where the intelligibility, where the background sound went up, wasn't there?
Yeah.
There was kind of more contextual effort coming in when it was trying to, was it this word or this word, kind of thing. So there was more of the kind of latter processing kicking in when it got harder. So that change in that lateral process might be quite a nice indicator of listening, what you might call listening effort, I guess. But it's a combination of a bunch of factors, I would think.
Yeah, but that's fascinating. I mean, that sounds like what can also be described as top-down versus bottom-up processing as well.
Yeah.
You're top-down trying to fill stuff in.
Yeah.
You know, people that have got a terrible auditory signal coming up, and they will do far better than somebody who's got a perfect set of auditory filters.
I thought the kind of pre-test stuff where they were looking, Will was looking at hearing ability, but was also looking at memory to retention, and it was kind of, you know, how many words, how correctly remembering sentences of different length and so on, because they're all kind of contributing factors.
Yeah.
So it was interesting to feed that into it, I think.
So when you were doing these tests and asking people to remember exactly what they heard, the words used, did you warn them that you were going to do that?
Yeah.
Because if you ask me, I'm not sure that I would bother trying to remember the exact words that were used. What I would naturally do is just try to understand what they were saying.
Yeah.
Right.
But to repeat something verbatim is, I think you'd need to warn me of doing that.
Yes, we didn't expect them to repeat it verbatim. We sort of showed the sentences to them, and they said yes or no if they'd heard that sentence. And so we basically what we told them was that you're going to be presented a series of sentences. Some of them will be taken directly from the stimulus, and some of them will have been altered in some way. But we didn't sort of specify how they'd be altered because we didn't want them to be looking for certain things. You know what I mean? We wanted them to just sort of sit and listen, and afterwards go, "Did you just hear this? Yes or no?" And kind of that way see by the mistakes they did make and didn't make.
I've definitely met people who would be able to repeat things verbatim. You know, these people do exist, but I'm not one of them.
We did have one participant who was like only said yes to the verbatim ones and like a few of the paraphrases, but none of the other ones. He was just wild. I was looking through his EEG for ages, just trying to understand his brain.
So either he's really, you could say he's really, really good at the word recognition stuff, or maybe he's deficient in the lateral processing, depending on.
When you bring human beings into it, it gets so much more
it does
complicated.
get messy.
It's like, oh.
Okay.
Yeah,
No.
Yeah, go ahead.
Again, we are fine for time.
Mental demand and listening effort.
Right, yeah.
How would they explain to the participants?
Right, so yeah.
Because they seem like the same thing to me. They look like the same thing in the graphs.
Yeah, they do. So participants did also find that quite confusing. It is confusing. So, I mean, kind of the reason, I don't know if you've come across the NASA TLX. So this was this is based on a kind of standardized sort of task load scale that was developed by NASA.
Is that the ordering lists?
No, so it's essentially scales like this, right. But like theirs, because they want it to be sort of across like a wider range of tasks, theirs is it's like physical demand, mental demand, frustration, I don't think they had engagement, I think it was temporal demand and effort. And so a few people have found this is quite an effective way of testing for listening effort, rather than asking people just how much effort was that, because that means completely different things to different people, as we've kind of already discussed, right? Is if you break it down into different aspects that sort of contribute to effort, people actually think about the individual bits a bit more. And so, yeah, mental demand and effort, a lot of people did find confusing, and they are very similar. There are like some sort of slight differences, but and they were very highly correlated. But the way we kind of described it was, the mental demand was like how much sort of mental activity was required, and specifically asked them thinking about like how much like thinking, interpreting, remembered. Like, was there a conscious thought while you were listening? Were you actually thinking about what's being said? Whereas effort, it was kind of framed as a kind of overall, like how much effort, how strenuous was it overall? How like did sitting and listening feel like just really automatic and relaxed, or was it hard work basically? And some people treated it quite differently. Some people treated it exactly the same.
And that would be right.
Yeah. But I do think that possibly it contributed to sort of the actual effort rating, because the effort rating was the last one of the scales. People kind of they thought through all these other things, then they gave the effort, and then it kind of meant that they'd actually taken more things into account rather than just going, yeah, it's kind of hard.
So it's coming on for 8:15, so probably time for one more question. Or I always think when you go to presentations and the question and answer is longer than the presentation, that's probably a good sign.
Yeah.
Ask one
awkward one. Oh, go ahead.
2 years in?
Yes.
You've done this set of experiments, you've done another set coming up.
Yes.
If I gave you a time machine, you had to go back and start again.
Yeah.
What would you change, if anything, about your first set of tests that is now in your head because you're planning your second set of tests?
Yeah, no EEG. It's too much like hard work. No, I'm joking.
I want the product for the studio with the EEG. That's.
Yeah, it's a good question. I don't know. I don't know off the top of my head. The first test, actually, all the results were quite interesting. We got quite lucky, I think. Like, everything kind of turned out with something interesting about it. Yeah, it's tough. I can't think of anything. I should have something.
You didn't say you weren't going to do EEG for the second set.
No, but that's mostly because it's going to be an online test. So, because obviously the EEG is quite limiting in the number of participants you can have. Where like there's only so many people you can fit into a day, and only so many days in a row you can goo people's head up.
So much hair you can fit.
Exactly. Yeah. So the next is going to be online, so we're not going to be doing EEG, but the kind of plan after that is to go back into another lab experiment and do something with the EEG again, kind of take what we find from the next experiment and kind of put that into some sort of, sort of Megazord type experiment at the end.
So the EEG response stuff and the response to the onsets and things like that inform the development of the enhancement processing, essentially, which is going to be tested in the next one. So it's seeing what the response is with the next one, and then you might have some regrets if we don't get anything out of the next experiment, of course. But
yeah, almost definitely.
But then potentially
Fingers
digging
crossed.
into that a little bit further with EEG might be useful beyond there, I think.
Okay. Yes, certainly, please.
The next experiment's going to be an online.
Yes.
So how do you control what people are receiving?
Right, I mean, as in sort of like the
it's
audio
online,
quality and.
You're transmitting one thing.
Is it going to be headphones or a crappy speaker or?
Yeah, so we're kind of obviously there's going to be some sort of variation that was going to be out of our control. So we're going to limit it to like you have to be on like a desktop computer, ideally with headphones. You need to have like decent speakers. It can't just be like phone speakers or whatever. Obviously, there's a limit to how much we can control that. We're doing it through Prolific, so that allows us to prevent phones or like.
Back to my first slide, they could play it through the TV.
Yeah, well, yeah. I mean, I wouldn't actually have a problem with them watching TV because part of the kind of appeal, I guess, of doing the online thing is it's actually people using their own devices. So, whereas like all this stuff is all well and good, like looking at these in a sort of lab condition, but how many people are going to be sat at home on, a pair of like £2,000 Genelecs set up in a perfect triangle? So, in a way, actually having people do it on their home devices is quite good, and we're going to obviously have like a survey at the start to find out what devices people are using, so we've got a bit of information about that, but there is going to be a certain amount of noise as a result of that.
Yeah, but you also get a bigger sample size.
Yeah.
That's the most important thing, getting more data in, so, more data comes with its own health warnings, but after going through the rigorous brain scans, I think that the data that we'll get from that will be quite interesting because it's a bigger sample size.
And will you invite people to take part, or will you just going to...
so the recruitment, like I say, again, it'll be through Prolific. So basically, we've got it set up so that we have like a nice spread of like fitting different sort of demographics. So like a spread across age ranges and genders, things like that. And basically, it'll just all be recruited through that. People who fit. The sort of requirements will just be, I suppose, send a notification. I don't actually know exactly how they send them out, but
Come back next year and we'll see how we're getting on.
Yeah.
Well, I think all that does is leave to thank you all very much for coming out. It was a very good session, and I appreciate the interaction with the audience. It was, as I say, smaller presentations, more discussions, always good. And on such a miserable night, it's not actually raining now, so at least that's something. So thank you all again. Really appreciate you taking the time out.